Here I'm going to explain ARM assembly language program to arrange 32-bit data in ascending order. Okay, first line is actually title TTL. Anything followed by TTL is a title for that program. So this, if you want, you can write TTL. Otherwise, you can write semicolon in the beginning, so that the entire line becomes comment. The program starts from second line, which is area. You can write ASC as the name of the area, and this is for ascending order. You can write any label, can be anything, and it is a code memory and it's a read-only memory. So second line export space underscore underscore two times underscore underscore main, and it is a label. Underscore main is a label which is written in the startup file. It is loading or not with underscore underscore main is a address. It is importing from the startup file. So same label we have to write in the this. So go to add new item, some file. So you can write ascending program now. You write any name, ascending order or ascend.s file. Okay. So like this you can write and click add, and you will get a editor. There you have to type this program. So here I already have the file. So if it is already there, you can just add that file, append, or you can add that file. So you are going to get this file. So here it's type program is typed. If you are doing freshly, then once you add .asm file, blank editor will be there. You have to type this program. Okay. Underscore main LDR R naught is equal to, this is a RAM address. Okay, this is a RAM address 0x1 followed by 70. So initially you have to load the data from this address only in the RAM address. So move R1 is equal to 5, because there is are 5 elements are there in an array. We have to arrange these 5 datas in the ascending order. So subtract R1 1. So you have to decrement by 1, because first data you have to compare with 5 data means 4 comparison is required. First number is compared with 2, next it is 3 compared with 3, next 4 with the 5. So this is we are using bubble sort method. So in the first comparison round, okay, since it is ascending order, the highest number will go to the right side most. Okay. So after completion of first sort round, okay, only the last highest number will be at the right side most. Remaining numbers are not in ascending order. So you have to do once again. So for that inner loop, one more time you have to compare. So every time if you do this bubble sort method, first highest number will go to right, next highest number will go to the right, next highest number will go to the next to that, next to that. Finally, least number will be at the left side. So this is outer loop, is the label. So all black colors are in label. For labels, no space. Okay, all instructions which are color in blue color, you have to give minimum one character space. So you have to use tab for each one, or you can use space bar. Okay, next in the outer mode we have move R3 comma R1. Okay, the move R1 is equal to 5 now. After subtracting by 1, we are loading that value. See, 5 subtraction 1 is 4. That 4 value is stored in R3. Once again, load R0 with this immediate value of the starting address of that memory where we stored 5 data. We have to store manually. So inner loop load R2 uh, within a bracket R0 means the content. Bracket means content of the address. So in this address, first data will be there. Now that will be copied to R2. And here you can see we are using pre-increment here. So in the largest number and all, we are using post increment. Here the hash 4 comes within the bracket only. So before transferring, it will add R0 with plus 4. So that y plus 4, because in ARM everything is 32-bit. 32-bit means 4 bytes. So 4 bytes we have to add. So R0 is pointing the first data. R0 plus 4 will point it to second data. So first data is loaded to R2, second data is loaded to R4. Next compare R4 with R2. Second number is compared with the first number. BCS. Okay, branch if carry flag is set. branch if carry flag is set here. That means if the first number, okay, if the first number is actually set, no, first number, I think this is reverse. The first number is less than second number. Okay, first number minus second number will take place. If I do compare R4, okay, R2 is first number, R4 is second number. R2 is first number, R2 is second number. Compare R4 and R2. Second number is compared with R1. That means second number minus first number. Second number minus first number. If carry flag is set means borrow. Okay, that is R2 minus R1. That is first number is greater. Sorry, greater only. If the first number is greater, then the carry flag will be set. So that time you have to do exchange. So copy R0 content to R4. Copy, sorry, store R4 content to address specified by R0. Store second number into first number and store first number into R0 plus 4 means this will be added with 4. So exchange will take place. First number will go to second place, second place number will go to the first place. This is the exchange code. I'm telling here in a store syntax is this is the source, this is the destination. Store here, first number is stored in R2, right? First number is stored in R2, second number stored in R4. Here R4 is moving to the first position address. R2 is posing to second position address. That means exchange is takes place. After that, again add R0 with plus 4 because we are going to previous number. Again, we have to add R0 with 4. Then subtract R3 by 1. So here, initially we loaded R1 with 4. Now after subtraction, 5 minus 1 is 4. So now once again, you have to subtract 4 minus 1, it is 3. Okay. So if it is not equal to 0, go back to inner loop. It will once again load R0 with R2. That means second number will go to here. Next third number will go to here. Compare those two. Okay. If first number is greater than second number, exchange will take place. Sorry, if it is the first number is greater than second element, it will go to here. Otherwise, exchange will take place. So this way we will get understand once I do the step by step. Okay. So compile this program. Okay, once all this first loop is over, highest number will be at the right side. Once again, you have to decrement outer loop, and again you have to go back to the here. This is stored in R1. You have to subtract that R1 outer loop R1. You have to decrement. If it is not equal, go to outer loop. So this is actually inner loop and outer loop. So we'll get some confusion. So only if you execute step by step, then only you'll understand properly. So let me start compile this program. Okay, 0 errors and 0 warnings. Start debug. So here, so get the address of underscore main into R0. So this is the address. Okay, it is coming to here. See, load R0 with this address. So in the memory window 1, you have to type this address 0x1 followed by 7 zeros. There, right click and modify the data. Modify memory at least. So here you can give any hexadecimal value. For example, I'll give some 4444 comma 0x a comma I'll type 0x33333333 then comma 0x 1 1 1 1 1 1 1. You can give any random data before exhibition only you have to give. Okay. So here I will give 9. This is random order I am giving. This is not in ascending order. You can see here 4A 3 1 9. 5 data were given. They are not ascending order. Okay. So according to bubble sort method, in the inner loop, first highest number A should come to this position. I mean remaining 4 are not in ascending. So next one more time if it repeats, next 999 will come here. Next 4 will come here. Next 3 will come here. Last 1 will come here. So that is the final output. 1 3 4 9 and A should come at the end. So let us see execute one by one. Move R1 with 5. You can see it will be highlighted with 5. So move R3, you are saving the same number in R3 also in the outer loop. Okay, same number is saved in R1 also 4, in R3 also 4. Once again load R0 with initial address. This is the address of our memory. Okay. After that, see here R0 is loaded with R2. Content of R0 is loaded with R2. That is 444 is loaded with R2. After that, the bracket within a bracket only we have hash 4. Okay, R0 is added with 4. We will get 1 followed by 7 zeros. Then it will be added with 4. So next data is AAA. AAA will come to, you can see, you can track this. This is 1000. You can see the right side here. First data is this. For this, if you add plus 4, 1001 followed by this zeros and 4. Next data is AAA. Once this location is red, it becomes red color. So that value will go to destination is R4. So it is loaded to R4. This is R2. This is R4. Now comparison. Branch if carry flag is set. Here you can see after comparison. Okay. It is doing 4444 minus A. Okay. Sorry. Ascending or descending, we'll check it out now. R4 comma R2. R4 is A minus 2. Okay. Carry flag is actually set now. What happens? Let us see now. If it is set, it should go to here. Because second number, highest number is at A only. So no need to exchange. Okay, no need to exchange. So carry flag is set. So it is skipped these two lines. See here. Which are executed, it is in green color. These two are skipped now. So in the skip, again you have to go to the next data, no? So next data is at 8. You can see the right side here. Next data is 333, which is at 8. So that's why you have to add R0 with 4. Okay, now it becomes, you subtract R3 by 1. Again load R0, R2 with the next data, which is AAA. Next load R0 plus 4 content into R4. So AA is compared with 3. Okay. Now compare R4 with R2. Compare R4. Compare R4 comma R2. Okay. Compare R4 comma R2. So no carry flag is set. You have to see the instruction how it works. Compare always lower number minus upper number will takes place. I think you can see R2 is actually AAA. This is 333. I think R2 smaller number minus higher number will takes place. I think so. Carry flag is actually 0. If it is set, then only skip. Otherwise, it will do exchange. R0 content will go to R4. See here, R0 is how much? 1004 location. Sorry, now R0 is how much? R0 is 1004, which is AAA. that will go to the R4 and 333 will come to this position. You can see in the memory. It is changed in the memory, not in the register. It is actually storing into the bracket. Bracket means from R4 it will load it to the content of address. In the address only it will change, not register values. It will change. Actually, it is changed in the memory because within a bracket we have written. So store R4 to the address specified by R0 and store R2 to the address specified by R0 plus 4. So again next you have to compare, subtract R3 by 1. Now R3 is how much? 2. If it is not equal, go to inner loop once again. Once again load new value of R0 into R2, R0 plus 4 into R4. So now it is comparing higher numbers A with 111. So it is comparing these two. To exchange between these two, it is checking. Again, the carry flag will be 0. So exchange will take place. You can see here, AA11 is exchanged. So again, now R1, R3 becomes 0. Okay, R3 becomes 0. So after the completion of inner loop, you can say here the highest number will be at A, but remaining numbers are not in ascending order. Okay, remaining number are not in ascending order. Only the highest number is at right side. Remaining numbers are not in ascending order. So that's why you have to subtract one more time R1. Original R1 here you can see 4. Still it is store only. Okay. In the outer loop we have here this one be above outer loop. Okay. Subtract R1 by R1 now. So this R1 value we stored in R3. So you have to subtract R1 by 1. Now it becomes 3. It becomes 3. It is not equal to 0. So once again you have to go to outer loop. Once again you copy that value to R3 and do repetition. You can observe now this. So here first it will compare 4 4 with 3 3. So exchange will takes place. Okay. Next it will compare 4 4 with 1 1. Exchange will takes place. Next it will compare 4 4 and 9 9. No exchange will takes place. Next it will compare 9 9 and AAA. No exchange will takes place. Okay. After that once again the target becomes 0. Still these three data are not in ascending order. The two loops actually first highest number at the right side, next highest number at here. So remaining these three are not. So again you have to see outer loop. 2 more times you have to repeat. Still R1 is at 2. So if it is not equal to 0, once again do this. It will compare 1 1 1 and 3 3. So no exchange. Next to 3 3 3 is compared with 4 4. Exchange will takes place. Okay. Once all becomes outer loop also R1 becomes 0. It will stop here. Stop B stop means branch to stop label which is here only. So it infinitely it will stay here only. So this is the end of the program and you can see the output. Final output is before execution you have to note down what is the sequence. After the execution you can see the data are arranged in ascending order. 1 1 1 1 1 3 3 3 3 4 4 4 4 9 9 9 9 A. So this is the output of arranging the 32-bit data in ascending order. For descending order, what you have to do is you have to change this one to instead of BCS, this is a branch to carry set, branch to label skip if the carry flag is set. So you have to do this one as branch to label skip if it is clear, BCC instead of BCS. CS means carry set, BCC means carry clear. Branch to skip if the carry flag is clear. BCC, CS means carry set, CC means carry clear. Okay, so that will show you in the next program.